Hi, this is Math 1650, and this video is over section 6.5. We will be looking at assessing normality. Determining if we have a normal distribution is very important because it determines what kinds of statistics we have to look at. When something's not normal distributed, sometimes we have to look at harder statistics. So there's three main steps with looking at this, each with their own level of whether or not we reject normality. There's other methods as well. We can get into higher statistics, but this is basically the baseline of what we look at. First, we construct a histogram, and we've seen this on how to do in StatDisk. And we want to see if it's a bell curve. So we reject normality if it's clearly not a bell curve. If it's close, we move on to the next step. We look at outliers. We reject normality if we have more than one. Now, this is something that can be sometimes negotiated based on the researcher and whether and how many data points they may have. And then we look at what's called a normal quartile plot. And we reject normality if points are not close to a straight line. Not close to a straight line. Now, normal quartile plot. This is a graph, like a scatter plot, graph of the point xy, where x value are from the original data, and the y value are a score corresponding to a quartile value of the standard normal distribution. In essence, we're trying to almost force the data points to be at certain intervals, and if they don't line up with a straight line, then they're not at those intervals. Okay, so there's 5 steps into constructing this by hand. It's even simpler to do on StatDisk. First is sort the data from lowest to highest. So what we're going to do is, as I go through these, I'm going to do in the next problem. So we have presidents and ages from 62, 46, 68, 64, and 57. We're going to sort this from lowest to highest. So 46, 57, 62, 64, and 68. Then we're going to identify 1 over 2n, 3 over 2n, 5 over 2n, 7 over 2n, and upwards. until we get to n minus 1 over 2n. So the numerator here is going up by 2, starting from 1, so it's every odd number. And then the denominator is just 2 times n, where n is your sample size. So n for us is 5. So we're looking at 1 over 2 times 5 is 10. So 1 over 10, 3 over 10, 5 over 10, 7 over 10, and 9 over 10. Okay. Then we're going to find the z-score for each percent in step 2. Right, so each of these has a decimal value 0 0.1, 0 0.3, 0 0.5, 0 0.7, 0 0.9. So we're going to put those into StatDisk, into our normal distribution. So 0 0.1, we get a z-score of negative 1.28. 0.3 be negative 0.52. 0.5 is 0. 0.7 is 0.52, and 0.9 is 1.28. Okay. Now we're going to plot. Let me write this in. Plot xy, where x is our sample values, y is the z-score. Right, so y is the z-score. That means we have to plot, anywhere from negative 1.28 to 1.28. So I'm going to make 3 lines here. This is going to be a negative 0.5, negative 1, negative 1.5. 3 lines on top. 1.5, 1, 0.5. And then with our president's ages, we're plotting from 46 to 68. So we'll count this by tens: 10, 20, 30, 40, 50, 60, 70. Okay. And I'm going to plot each point together. So the 46 goes with the 128. The 68 goes with the positive 128. And 62 goes with 0, and so forth. So negative 1.28 in the y and 46 in the x. So 40, about halfway through, about here. Then 57 and negative 0.52. 10, 20, 30, 40, 50, about halfway through that one onto here. And then 62 and 0. Right on here. 64 and 52. Up here. And 68 and 1.28 on here. And so we're looking at a line coming through here. And so it's pretty close to a line. Points in a straight line. And so we look to have a normal distribution. Right, so let's put the data in. stat disk. So let's clear all this data out. Put in the 5 ages. Doesn't matter if you put them in order or not. To do a normal quartile plot, we're going to do it 2 different ways. First way, actually 3 different ways. One way is you can go explore data and choose a column. And it's the last one here, and we can see it's pretty close to that straight line. Another way, we can just go to the normal quartile plot. And here we can take away the regression line if we need to, if we want to. Or we can put it back. Right, but it's pretty much the same plot. We really can't do anything else. We can title it, but that's about it. So it doesn't really matter which one you look at there. Again, we can see the points are pretty close to that straight line. The third way, the way I kind of suggest, is what's called a normality assessment. So we click on that, select the column, and only because it provides a lot of useful stuff with determining the normal distribution. One, it provides a histogram, so we can see this is, for the most part, bell curve. It provides the normal quartile plot, which is close to a straight line. It provides the number of possible outliers. So one of them is below and towards the low side, and 0 above. So this data set only has one outlier. Right. And then we won't worry about the stuff up top here, but we can look at this fail to reject normality, and it fails to reject normality in both levels there. So this the normality test with it that we have is saying that it can't reject normality. So there is evidence that we have a normal distribution here. So a couple of things to look at. Now, it is possible that one significant level will reject it and one will not reject it and fail to reject normality. So that's something to watch out for. But let's go back to some more. We're going to look at different data sets now. So we're going to start with the 14th edition, earthquakes and depth. So let me actually clear this data. 14th edition, earthquakes. Oh, it's not here. It is 24. And there you go. And then depth is your column we're going to be interested in. So we'll go to normality assessment because it has everything we need here. And depth. And so we'll start with the histogram. Doesn't quite seem all that great of a normal distribution there. Now, for the most part, you probably would stop and say, okay, yeah, it does not seem like it's normal. We can just move on to the plot, just see what we see. This is nowhere near that straight line. It jumps up around, but it's significantly away from it. So the normal quartile plot is also not normal. Then we can look at outliers. We're at 36 possible outliers. And then we can see that it's rejected on both levels. So we will reject normality here. Right. And so let me go back to what I've written. So not normal for both histogram and plot. 36 outliers. Reject normality. All right, let's go to the magnitude. Okay. The bell curve is close to a bell curve for the histogram. And it's for the normal quartile plot, it's close to the line, but not at the ends. Usually that happens a lot of times is on the quartile plot, it's the ends that get kind of thrown off. So we have 5 outliers. And so if you notice, we reject normality in both levels. So this data was closer to a normal distribution, but still wasn't a normal distribution. Alright, so now we're going to open up body data for the 14th edition. We're going to look at height and arm circumference. So go back to the data set, clear this, open up 14th edition body data. And we're going to do normality assessment. And I said height, we'll do that first. Bell histogram looks like a bell curve. The normal quartile plot is very close to that straight line. Even on the ends, it's pretty close. Maybe on the top, it gets a little bit farther away, but not much. So it's a straight line. Only one outlier. And if you look, we're failing to reject normality on both levels. It fails to reject normality. Right, so let's look at the arm circumference. Okay, the histogram is a decent bell curve. The normal quartile plot is not as good as the height, but it's pretty close. So it's close to a straight line. One end is a little bit farther than we may like, but it's still pretty close. 0 outliers. Again, fails to reject normality. Okay, so we're looking at 2 sets here that are pretty close to normal. Now we're going to look at 2 more sets, car data. We're going to look at city miles per gallon and highways miles per gallon. So let me clear the data here. 14th car data. What is it? Yeah, it's 35. I didn't click on 35. So now I know where it's at. Alright, we're going to look at again city miles per gallon, highway miles per gallon. So we're going to go to data, normality assessment, do city. Okay, so bell curve. The histogram is somewhat of a bell curve. It's close enough to keep going with this. The normal quartile plot, you have to be careful with this. There's a lot of plot points that are the same values, so it's going to be kind of like in these lines. Most of the lines are pretty close to the actual line itself. So when you see something like this where a lot of values are happening at the same points, you gotta kind of take them overall. You know, does the gist of them fall very far from the line or not? These points down here are a little bit too far, maybe, but it's still somewhat of a straight line. Zero outliers. And then we see on this, it rejects normality at 0.05 level, but fails to reject at a 0.01 level. So that's where things can get a little bit confusing. Basically, we have evidence that we can reject it as long as our significant level is high enough. But if our significant level is too low, then we don't have enough high enough significant level to reject it. So with this, I think, and especially with the quartile plot being a little bit farther on these ends, I would reject at 0.05 level. Okay, let's look at the highway. Here, bell curve for your histogram. Normal quartile plot, very similar. It's somewhat of a straight line. Oh, my tablet is saving it again. The outliers are 0, and here we fail to reject. Alright, so with the car data, the city miles per gallon, that data we could reject normality at 0.05 level, which is not 0.01 level. And then the highway, we failed to reject normality, so we kind of had normal distribution there. Alright, so that is a normal quartile plot. In the next section, we'll get into actually something a little different. We're going to be approximating the binomial distribution with a normal distribution. I will see you then. Bye.